So we are starting with definite integration, and in definite integration we are taking properties of definite integration. Properties of definite integration. Today we are going to see some properties and we will also see their proofs. We will prove them. Few of the proofs of this definite integration are asked in exam quite often. So we need to know how to prove them. So let us start with the properties of definite integration and their respective proofs. So property number 1, a to b f of x dx is b to a is b to a f of x dx but negative. So here what we have done, we have inverted the interval a to b, and on the right side you have b to a f of x dx. They are equal negatively. That is, if you evaluate this, you get answer for this. For example, say you get answer for this as 6. So answer of this will be negative 6. Answer of this will be negative 6. That is why you put outside negative sign. So what will happen? This negative with this negative will make it 6, and then you can write they are equal. So what you wrote a to b f of x dx as negative of b to a f of x dx. Then property number 2, a to b f of x dx is equal to a to b f of t dt, I'm sorry, and which is equal to a to b f of y dy. Now what does this result mean? It means that if you have the same interval, see a to b, a to b and a to b, if you have same interval for the definite integration and you have same function, see function is f in all the three integrals. Am I changing the interval? No. Am I changing the function? No. So if I want, I can change the variable. I can change the variable. Here it should be y, not x. So I kept the interval same and I kept the same function. I could change the variable. So a to b f of x dx will be same as a to b f of t dt, which is same as f of a to b f of y dy. That is, if the answer for this is coming 3, you evaluate this will be 3 and this will also be 3. So the change of variable will not make any difference so far as the value of the integral is concerned if you keep the same variable, sorry, if you keep the same interval and same function. Then we have the next property, which is property number 3. See, property number 3 is a to b f of x dx can be written as a to c f of x dx plus c to b f of x dx. Okay, that is single integral. Here on the left you have single integral which you wrote as the sum of two integrals, that is a to b. You wrote a to c and c to b. You could do this provided you can do this provided you notice that this number c is in between a and b. That is, number c is greater than the lower limit. It is greater than the lower limit but lesser than the upper limit. So c is greater than a but lesser than b. If you have this, you could write this way. You can use this property. I will give you an example for this. Let me give you an example for this. Which one? The third one. Okay, I'm writing the example here. See, the example is, suppose you have suppose you have 3 to 7 f of x dx. Okay, some function you have which you want to integrate in the interval 3 to 7. Then you will be able to integrate this from 3 to 4 f of x dx and 4 to 7 f of x dx. Why so? Because you notice that number 4 is greater than 3 and lesser than 7. So 3 to 7, you could write 3 to 4 plus 4 to 7. Okay, if you want, you can break it furthermore. Every time you need to understand that the new number that you are introducing, it is greater than the lower limit but lesser than the upper limit. Okay, I hope you all must have understood this. So these are the three properties. Okay, then see, let me first write all the properties, and then one by one I shall prove them all. So this is third property. Now property number 4. See, the fourth property is 0 to a f of x dx is equal to 0 to a f of a minus x dx. Okay, that is, if you keep the same interval and the same function, you could write the variable in the integrand. This is integrand. Okay, so here what I did, I kept the same interval 0 to a, and I kept the same function which is f. The function is same. If I do that, if I maintain this, I'll be able to write the variable x as upper limit minus x. I'll be able to write the variable x as upper limit minus x. I will give you an example for this. The example would be, suppose I have to integrate 0 to pi by 2 sine of x dx. Now here what I understand, the interval is 0 to pi by 2, so I will keep it 0 to pi by 2. The function is sine, so I will keep it as a sine, and the variable is x. So what I'll do, I will write variable as upper limit minus x. Now what you notice is, what you will get is this, in this integral and this integral, they will have the same value, that is they are equal. That's why we have this equal to sign in between. Okay, so this is example for property number 4. I will give you one more example for property number 4. Suppose you have to integrate 0 to 7 x square dx. So the function is x square. You still write 0 to 7. The function is x square. You don't change that. The only thing that you are allowed to change is the variable in the function. So x, I'll be writing 7 minus x, the whole square, and dx. So see what I did? I kept the same interval 0 to 7. Yes. I maintained the function x square, variable raised to constant. See, this is also variable raised to constant. The only change that I brought in is the variable x has now been written as 7 minus x, the whole square. This is property number 4. Then we have the next one as property number 5. The property number 5 is, you have a to b f of x dx, a to b f of x dx can be written as a to b f of a plus b minus x dx. Okay, what does that mean? It has almost the same concept as property number 4. See, in property number 4, you had 0 to a. So you maintained that on the right hand side integral as well. Here you have a to b. So a to b, you maintain it. You still write a to b. Do I change the function? Here I have function as f. No, I maintain the same function. It is still the same function f. Okay, the function isn't changed. Okay, so what is the change? The change is On the left hand side, I have the variable in the function as x, where on the right hand side, the variable is lower limit plus upper limit minus x. I repeat, what has x been replaced by? X is replaced by lower limit plus upper limit minus x. Lower limit plus upper limit minus x. So I will give you an example for this. The example would be as follows. Suppose I have to integrate pi by 6 to pi by 3, pi by 6 to pi by 3, tan x dx. So I still write this as pi by 6 to pi by 3. The function is tan, so I maintain it. It is still tan. But now instead of writing x, see, it is tan of x. It is tan of x. So instead of writing x, I will write lower limit. X will be replaced by lower limit plus upper limit minus x and dx. Okay. So I hope you all must have understood this. This is property number 5. Now I go for property number 6. See, property number 6 is 0 to 2a. 0 to 2a f of x dx is equal to 0 to a 0 to a f of x plus f of 2a minus x dx. Okay. Now what does this property say? This property says 0 to 2a f of x dx. Okay, the interval is 0 to 2a and the integrand is, this is integrand. Okay, and this is interval 0 to 2a, the interval in which the function is being integrated. So what I noticed that the interval is 0 to 2a on the left hand side integral, whereas on the right hand side integral the interval is 0 to a. So I understand that interval has been halved. It has been halved. Okay, on the right you are writing half the interval which you have on the left. So on the left you had the interval from 0 to 2a, but on the right you have the interval from 0 to a. Only this, the interval has been halved, okay, on the right hand side. So you could do it provided you maintain some condition, you follow some condition. The condition is this integrand is now written as sum of two functions. What is the first one? The first one exactly the same, f of x. The first one is exactly the same, f of x. But the second one, the function is same, f, but the variable is upper limit minus x. The variable is 2a minus x. The variable is 2a minus x. I will give you an example for this. I shall give you an example for this. So the example will go as follows. Suppose I have to integrate 0 to pi sine of x dx. I'm giving you an example for property number 6. Suppose you have to integrate 0 to pi sine of x dx. Now, what does this property say? This property says that you can half the interval. So 0 to pi, you can write 0 to pi by 2. See, it becomes 0 to pi by 2. You can do that provided the function that you are integrating, the integrand that you have here, which is sine of x, you will have to write this as sum of two functions. The first one, see, I've got a plus sign in between. So here the first function and the second function. The first one will remain exactly what you had on the left hand side, which is sine of x. But the second one will be, the function will be sine, but its variable won't be x. What it will be? It will be upper limit minus x, that is pi minus x. And now the right hand side integral will have the same value as the left hand side integral. I hope you all must have followed this. This is property number 6. Then we have the property for even and odd function. The seventh one is property of even and odd function. So the property of even and odd function, I shall tell you that in a short while. Okay, so before I take the next property, I shall quickly revise these two types of function, that is even function and odd function. These two types of functions we have done in the topic functions in 11th standard. So what kind of functions are known as even function, that we are going to see, and then we will see which type of functions are known as odd functions. So let's have first even function. A function f, okay, a function f is said to be an even function if f of negative x and f of x, they are equal. I repeat again, you have a function f, you have a function f such that if you find f of negative x, you will notice it is same as f of positive x. So if you are thinking how is that possible, I shall give you an example for this. So for example, I'm sorry, for example, let f of x be cos of x, f of x be cos of x. Now let me find out f of minus x. You know, if f of x is cos x, f of minus x will be cos of minus x or cos of negative x. Now we all know that cos of negative x is same as cos of x. So f of minus x is also cos x. So what you notice from these two, you understood that f of minus x and f of x, they are same. So this function here, that is cos is an even function. So you can say therefore f of minus x equals to f of x in this case. Why? Because it is cos function. Hence you can say f is an even function. F is an even function. I can take one more example for this. Let me have another example for even function. Example for even function. Example number 2. Let f of x be x square. So you know, if f of x is x square, therefore f of minus x will be negative x square. F of x is x square, so f of negative x will be negative x square. Now you know, if you square negative x, that is you multiply negative x with negative x, it will again be x square. So f of minus x is x square. Once again, what you notice that f of negative x and f of x, they both have same value, x square. So you will write therefore f of minus x equals to f of x, and hence you can say therefore f is an even function. It is an even function. So remember students, what is an even function? A function f is said to be an even function if f of minus x is equal to f of x. Now we come to the odd function. What is an odd function? A function f is said to be an odd function if f of negative x is negative of f of x. F of negative x is negative of f of x. Here what you had written, you wrote f of negative x is same as f of x. But here f of negative x will be negative of f of x. So let's do this. So here I will give you an example. The example F, for example, the first one, yes, you thought correctly. We are going to take sine of x. So I write here, let f of x be sine of x. When I go for f of negative x, it will be sine of negative x. And as you all know from the knowledge of trigonometry, that sine of negative theta is negative sine theta. What you know is sine of negative theta is negative sine theta. So sine of negative x will be negative sine x. So f of minus x is equal to minus of sine x. So f of negative x is equal to negative of sine x. So from here, this one and this one. Now this time what you notice, f of x and f of negative x, they are not equal. They are not equal. So what you notice is sine of x is equal to f of x. So here I can write f of x. So I will get f of negative x is equal to negative f of x. F of negative x is negative f of x, and hence I can say, hence f is an odd function. F is an odd function. I can take one more example for this. For odd function, example for odd function. This is example number 2. Let g of x equals to x cube. I can take the function symbol as a g as well. Okay, f, g, h, all of them are equally good. So I can take g of x as x cube. Now, what I do next is I write g of negative x. So g of negative x will be negative x cube. G of x was x cube. So g of negative x is negative x cube. Now you know negative x cube. So you multiply negative x thrice. So when you multiply negative x thrice, the result will be negative of x cube. So g of minus x is minus of x cube. Now you check these two. What do you notice? Is g of x same as g of minus x? No, no. They are not equal. X cube is g of x. So here I can write, for x cube I can write g of x. So what will that give? What will that give me? It will give me in the next step as g of minus x is equal to minus of g of x. So I can say hence g is an odd function. G is an odd function. I hope you must have all understood what is even function and odd function. Please make a note of this too. Now we will take property number 7. After having understood what is even and odd function, we are now in a position to understand property number 7 of definite integral. It says that negative a to a f of x dx will be equal to 0. What does it say? It says that negative a to a f of x dx will be equal to 0 if f is an odd function. If f is an odd function. Okay, let's have a discussion on this. The interval is quite specific. You have the interval here, negative a to a, and you are integrating the function f of x. Now, whatever be the function that you are integrating, if the interval is of this type, that is negative of a real number to positive the same real number, then the value of this integral will be 0. no matter what the function is. So let's have an example. Suppose I integrate negative pi by 2 to pi by 2, and I have here function sine of x. Is this function sine of x an odd function? Is this function sine of x an odd function? The answer is yes. Sine of x is an odd function. We have just seen this. Okay, I just showed it to you. Sine of x is an odd function. You saw here. Sine of x is an odd function. So you don't have to think twice. You can write the answer as 0. I take another example. Suppose I have negative 5 to 5, and I have to integrate x raised to 3 dx. What will be the answer? The answer will be 0 once again. Why? Because x cubed is an odd function. So this is property number 7. I wrote the property. I also solved. I also gave you example for this. Now, you would be thinking that this is when f is an odd function. What happens if f is an even function? You are right. If f is an even function, then this negative a to a f of x dx is 2 times, it is 2 times integral 0 to a, 2 times 0 to a f of x dx. If f is an even function, if f is an even function, so what you wrote, negative a to a f of x dx is 0 if f is an odd function, and negative a to a f of x dx is 2 times 0 to a f of x dx if f is an even function. So I give you an example for this. If you have minus pi by 2 to pi by 2 cos of x dx. Now, as you all know, students, cos x is an even function. This I could write 2 times 0 to pi by 2 cos x dx. Cos x dx. So this is example for even function. I write one more example. If I have negative 2 to 2 x squared dx, then this could be written as 2 times 0 to 2 x squared dx. Minus 2 to 2 becomes 0 to 2. Don't forget that it is 2 times of 0 to 2. So I hope you all have understood what is property number 7. Now, one by one, we will prove all these properties. So now I will start with the proof of these properties. Okay, before I give you the proof of these properties, I would like to make some statement on these. See, the first 3 properties, that is these 3 properties, they have got one single approach. For learning the proof of these 3 properties, you will notice that you have a single approach, whereas these 4 properties, the fourth one is here. The fourth one is here. That is property number 4 to 7. They have another approach. So let us begin with property number 4. What I will do is I shall start proving fourth. I will first prove the second lot of the property, that is fourth, fifth, sixth, and seventh. Then I shall prove first, second, and third for you. So let me first prove fourth, fifth, sixth, and seventh. Then I will go for first, second, and third. So I will begin with the fourth property. So what am I supposed to prove here? I am proving, see, the fourth property is proof. The number isn't important. The number isn't important. What is important is the proof, whatever number you give. So here I have fourth property. To prove that 0 to a f of x dx is equal to 0 to a f of a minus x dx. I have to prove this. This is fourth one. Okay, fourth for R number. So here I will begin with the proof. See students, I have to get this left hand side and right hand side equal. What I will do is, I will begin with my left hand side by considering it as integral I. By considering it as integral I. So here I write, let I equals to 0 to a f of x dx. What is it? It is nothing but the left hand side integral. Okay. Now, in order to learn this proof, you will have to follow some techniques which I am going to tell you, and be very alert. See, what I notice is when I start with the left hand side, taken this as I will keep continuing, and at one stage I should be, the left hand side is I. You know, this all will remain I. So I'm going to work on this. I'm going to work on this. Okay. And I shall be continuing to write something for this, that is some mathematical ideas. And at one point in time, I should end up with the right hand side, that is 0 to a f of a minus x dx. This is what is my aim. I will begin with this and I shall want to end up with this. Now, when I end up with this, I will say that these two are equal. What I would say? I would say that this is equal to this, because here left hand side is I, and I'll be able to replace, see, this is left hand side I, but now I know that I is this, so I'll be able to replace this I by 0 to a f of x dx. So this is what is going to happen, and if this happens, I'll be able to complete the theory. Now the question here is that how do I do it? How do I achieve this? So now you follow the trick. See, the trick here is, I notice that on the left, I have got f of x, and on the right, I have got f of a minus x. So I would ask myself that somehow I should get, in place of x, somehow I should get a minus x. See, this is what is my task. This is my task. I call this as my task. What is my task? My task is that on the left I have got f of x, on the right I have got f of a minus x. So somehow I should get, in place of x, look at the arrow. Look at the arrow. It originates from x, which you have started with, and it ends up to a minus x, which is your goal. So I will ask myself that somehow this x should be converted into a minus x. And remember students, once you get this, the next thing is you will on the right, that is, what is your goal? Your goal is this. So what is your goal, where you want to reach? There, the variable x you will replace by t, and that is your substitution. That is your substitution. What does that mean? Wait for a while. Okay, so here, see, if you follow this technique, the theory is over. The theory is over for you. So see here, how do I begin? I will write put x equals to, I begin with this is my left hand side, I took it as I, then what I write, I will write put x equals to, see here, put x equals to a minus t, put x equals to a minus t. And how do I get this a minus t? I just told you, students, I just told you, what did I ask myself? I asked myself that somehow this x should be changed into a minus x. So this x should be changed into a minus x, and on the right, which is my goal side, I replace x by t. So this becomes a minus t, and that is my substitution. That is my substitution. That is, x should be converted into a minus x. So I put x as a minus t. So this is, I write put x equals to a minus t. Now I go for, as you all know, students, in integration, when you do the substitution, the next step you do is you differentiate. So here I write differentiating with respect to t. Whichever you want, you can also, if you want, you can differentiate with respect to x also. I'm differentiating with respect to t. So here I get d by dt of x, and on the right I get derivative of a is 0, which is a constant, and derivative of t with respect to t is 1. So I get here dx equals to, this dt will multiply here, 0 minus 1 is -1, -1 into dt is dx is negative dt. Okay. The next step is I will now change the limit. Changing limit is essential. Why? Because this limit which you have, it was for x. You are going to substitute. What are you going to write? You are going to write x as a minus t. So the next step you will write here, when x equals to 0 and when x equals to a, when x is 0 and when x is a. So when x is 0, see, you have 0 equals to a minus t. So you have negative a as negative t. So t equals to a. And when x is a, so you have a equals to a minus t. So you have 0 equals to negative t. So t equals to 0. So now you understand that x interval, which was from 0 to a, is now for t. For t, it is a to 0. So the new integral, now it is time you wrote the new integral. So I equals to, you won't be writing 0 to a. That 0 to a was for x. So what would you be writing? You will be writing a to 0. A to 0, f of x. You are not writing x. You are going to write x as a minus t. A minus t, and then dx. You won't be writing dx. What would be you writing? You would be writing negative of dt. Okay, the next step is this negative sign comes out. So you have I equals to negative a to 0 f of a minus t and dt. A minus t and dt. Now, this is time I used the property number 1. You remember what was that property number 1? It was this. See, if you have a to b f of x dx, if you have a to b f of x dx, you could write it b to a, provided you write negative, sign. So here what I'll be writing, see students, I have a to 0. I want to write this as 0 to a. I want to write this as 0 to a. So the next step I write here, I write the property which I'm going to use. I write here using a to b f of x dx equals to negative b to a f of x dx. We get, what are you going to get when you use this? See, I use this property here. So I equals to Now, everybody, see this. It is a to 0. I want to write this as 0 to a. A to 0, I wrote 0 to a. Now, the moment I write 0 to a, I would have to write a negative sign. This is a to 0. When I wrote 0 to a, I would have to write a negative sign. Now, that negative sign with this negative sign, it will become positive. So the next step when you come here, you will not get negative sign. This is positive. Why this is positive? Because it was a to 0 negative. I wrote it 0 to a, so I will put one more negative sign. As I inverted the interval, negative with negative will become positive. Okay, and here you have f of a minus t dt. Now this is time when I used property number 2. See, what was property number 2? Property number 2 was that if you have a to b f of x dx, you could write it as a to b f of t dt. That is, this is known as the property of change of variable. If you maintain the interval, you do not change the interval. See, a to b, both sides a to b. If you maintain the interval and you maintain the function, the change in variable is allowed. So you have a to b f of x dx, you have a to b f of t dt. A to b function is f, the function isn't changed, so the variable x can be written as variable t. So when I use this property here, I write here, using a to b f of x dx is equal to a to b f of t dt. We get, what do I get? I get here I equals to, I will get here I equals to 0 to a, 0 to a. See, I maintain the same interval and I maintain the same function f. Now I'm allowed to change the variable. So a minus t dt will become a minus x dx. And mind it, students, this is the end. This is the end of the theory. You have proved it. You begin with 0 to a f of x dx, and you ended up with 0 to a f of a minus x dx. You ended up with 0 to a f of 0 to a f of a minus x dx. So the next step is you can write I. What was I? I was this. So you can write therefore 0 to a f of x dx is equal to 0 to a f of a minus x dx. Hence proved. Hence proved. You can write this theory in your notebook and practice this again and again. Very simple theory. I told you the trick to be remembered. This trick is the key. This trick is the key for writing the theory. You understand this, you get the theory very easily. Now we will begin with property number 5. The fifth one is to prove that a to b f of x dx equals to a to b f of a plus b minus x dx. So I shall begin with the left hand side. I will begin with the proof, and as you know, I will start with, I'll write let I equals to my left hand side, which is a to b f of x dx. Okay, once again, what is my aim? My aim is to prove that a to b f of x dx is a to b f of a plus b minus x dx. So when I start with my theory, I understand that for this thing, I would be writing something here, then something here, then something here. And finally, at one point in time, I would be saying my theory is over if I get a to b f of a plus b minus x dx. So I begin with this, and I continue writing, and then at one point in time, I should get my RHS. So I will say, this is all I, this is all I. So I say that this and this, they are equal because this is nothing but I. This is nothing but I. So here I will say that a to b f of x dx is equal to a to b f of a plus b minus x dx. So if this all happens, I get the success. That is, I complete my theory. But now the question is that how does this happen? How do I complete it? How do I achieve it? See, here I now tell you the trick. The trick is once again what I had told you for property number 4. I noticed that on the left I have got f of x. On the left I have got f of x, but on the right I have got f of a plus b minus x. I've got a plus b minus x. So I tell myself, I ask myself to transform this x, which is on the left. Okay. In place of x, I should be getting a plus b minus x. This is what is my task. This is my task. What do I have? I have x. And what is my goal? My aim is to get a plus b minus x. And now, what is your goal on that side? This variable x, you shall be replacing it by t, and this completes your substitution. That is, you will write x as, you will put x as a plus b minus t. What is your substitution? Substitution is you put x as a plus b minus t. So I got my substitution. I begin with my theory. I shall now be proving it. So see, how do I begin? I will write put x equals to a plus b minus t. As you all know, now after substitution in integration, we always differentiate because the differential has to be changed. Here it is x. When you are putting in t, you should be getting dt, and that is only possible when you differentiate. So I differentiate with respect to t. I get d by dt of x, and here I get d by dt of a plus b minus t. So this gets me dx by dt on the left, and on the right, derivative of a is 0, derivative of b is 0, derivative of t with respect to t is 1. So I get 0 minus 1, so that is minus 1, and this dt multiplies here. I get dx equals to negative dt. Okay. Now before I write the new integral in t, I shall have to change the limit. Why changing limit is important? Because you now have new interval. You have new interval, that is, sorry, you have a new variable, that is t. So here I will begin with it. I will write when x is equal to a, it is from a to b. The interval for x was a to b. So when x is a and when x is b. So I write here, see, when x is a, okay, here I substitute a, I will get t. So a equals to a plus b minus t. So a cancels, you get negative b equals to negative t. This gets you t equals to b. And when x is b, substitute x as b here. So you'll get b equals to a plus b minus t. B cancels. You get negative a as negative t. So t equals to a. So now what you have is the integral I equals to a to b f of x dx. Okay, now you write the new integral. So you have here I equals to a to b f of x dx will become b to a. It will become b to a, and f of x dx, f of x. What is x? X is a plus b minus t. See, what did I do? A to B will become B to A because I'm going to use the substitution. I'm not going to write X anymore. In place of X, I'm going to write this. So when I'm going to write this, I shall be writing the new interval, new limits. Okay. So X is A plus B minus T. So F of you have A plus B minus T. And what is dx? Dx is negative of dt. Now, as we did in the previous theory, this negative sign will come out. You will have I equals to negative B to A F of A plus B minus T dt. Now this is time I use the property. Why I use the property? Because it is B to A and I want to write it A to B. I want to write it A to B. So here I write using, I write here using A to B, using A to B f of x dx as minus of B to A f of x dx. What am I going to do? I'm going to write A to B f of x dx as minus of B to A f of x dx. Okay, so when I do that, see, we get, and where am I going to use this property? I will use the property here. I will use the property here. Okay, so students, see, what do I get? I equals to, this is B to A. So B to A, when I write A to B, now listen, I invert the interval B to A, I wrote A to B. The moment I do that, I will have to put a negative sign. And that negative, with this negative, it will become positive. So outside, I shall not be writing any sign because writing no sign is an indication of positive sign. So it becomes A to B and f of A plus B minus T dt. Now it is time I change this T to X. And for that, I will use once again one more property, that is change of variable. And what is that property? The property says using A to B f of x dx is equal to A to B f of t dt. That is, if you maintain the same interval and same function, changing the variable is allowed. So when I use this property here, see, what do I get? I will get here I equals to, I will get here I equals to A to B. It is f of, I don't change the function, I don't change the interval. Now I am allowed to change the variable. This is A plus B minus X dx. And my dear students, it is all over. We have completed the theory. We have proved that, hence I can say, therefore, I can say that A to B f of x dx equals to A to B f of A plus B minus x dx. Hence proved. Hence proved. I want that you all write these theories in the proofs in your notebook, and then you should practice them several times in order to remember how to write it. And don't forget that this trick is the key. If you know the key, you can open the lock. Don't forget the key. If you don't have the key, the lock will remain unopened. So this is property number 4. This is property number 5. Okay. I hope you all have followed the property, the remaining properties I shall be proving in the next video. Thank you.